This problem asks us to evaluate the integral from 0 to 1 of x squared plus 7 times e to the negative x. We're going to use a technique called integration by parts to solve this, because we basically have two functions multiplied together that we'll call u and dv. And integration by parts tells us that that integral becomes u times v minus the integral of v times du. And we'll get to more on that in a bit. For now, let's split up the original problem into two pieces. We'll let u be equal to x squared plus 7, and dv be equal to the rest of the original problem, which is e to the negative x times dx. We'll need some more information to fill in the formula, so we'll take the derivative of u, which is du 2x times dx, and the antiderivative of dv will give us v, negative e to the negative x. We can take these values now and insert them into the integration by parts formula. U is equal to x squared plus 7 times v, which is negative e to the negative x, minus the antiderivative of v times du. We found v to be negative e to the negative x, and du to be 2x dx. We'll turn these two negative signs into positive signs to keep things simple. And realize now that we still have an antiderivative that we have to do. So we'll do a second round of integration by parts. When we choose u, we often want to pick the part of the equation that with enough derivatives would eventually become 0. So here we'll let it be 2x. dv then is the rest of the expression, which is e to the negative x times dx. We'll take the derivative of u to get 2 times dx. The antiderivative of dv is v, which is negative e to the negative x, as we'd seen before. At this point, we'll rewrite the values that we had already found from earlier in the problem, namely the x squared plus 7 times negative e to the negative x, and then proceed with integration by parts for the next interval. Our u that we had just chosen was 2x times the v of negative e to the negative x, minus an integral of v times du, which is negative e to the negative x for our v, and the du was 2 times dx. We'll change the negative signs to positive once again. And observe that in that remaining integral, it's actually quite a simple integral for us to evaluate on our own. So this problem is very nearly complete once we take that extra step. Taking just a moment to recreate the parts of the problem that we had originally solved gives us x squared plus 7 times negative e to the negative x minus 2x times e to the negative x. And the antiderivative of e to the negative x times 2 is negative 2 e to the negative x. At this point, we have finished taking the antiderivative. And all that remains is for us to take the two boundaries of 0 and 1 and to put them into this antiderivative. Once we've put those numbers in, we'll subtract the two results from each other, and that will give us our final value. So the first steps that we're doing are to plug 1 in for x wherever we see it. 1 plus 7 times negative e to the negative first minus 2 times 1 times e to the negative first minus 2e to the negative 1. Then we subtract the results here in the square brackets, the result if we plug in 0 for x. Fairly simple to do, and this expression in the brackets will collapse very quickly once we do those calculations. So here on the left we see a number of terms that have an e to the negative 1 in it. So we'll set about combining those like terms in short order. 8, negative 8 times e to the negative 1 minus 2e to the negative 1 minus another 2e to the negative 1. And in the square brackets, we have so many zeros in there that all that remains is -7 minus 2. We can combine all of these terms with e to the -1 to get -12e to the -1 plus 9, which is the answer to the problem.